Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening, and my name is Julie Tomei. And this evening, I am joined by Dr. Elena Hyde. Hi, Elena.
Hello, everyone.
And for the first time, Parisa Nazari. Hi, Parisa.
Hi, everyone.
Welcome. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 1 a.m. Universal Coordinated Time, if that's more your speed. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 and 10 p.m. local Toronto time. Head over to our website at www.yorku.ca/science/observatory and follow the links to OPV for online public viewing and join in the chat for any questions or comments you have or past shows. And if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on socials. On Instagram, we are at Yorku Observatory, and over on Facebook, we are Allan I. Carswell OBS. Our programs are all free, but if you would like to make a donation, we won't say no. There's a button on our website for that. And that website again is www.yorku.ca/science/observatory. We'll be monitoring the chat room for any questions, posting some content there if as necessary. The current weather is good. The dome is open, right, Elena?
It is. It is open, and we are working on getting it, of course, ready to go. It is unfortunately still a bit bright, that pesky summertime, with its sun and not being a little too bright outside. But hopefully, we'll be able to get on sky soon and go to some targets that are bright enough to outshine the twilight.
All right. So starting with archival images and then moving on to some live images over on the online public viewing. Okay. So this is so exciting. We have a new host.
Indeed, and it's a hearty welcome to our new host, Parisa Nozari. So let me just go ahead and do a short introduction, just in case you don't happen to know about her already. From great fame in 2022, she has an amazing astronomer in residence blog archived with us. I encourage everyone to go read it. It's really, really good. Parisa Nozari, she's an astronomer, and I believe you're still at Queen's University, right?
Yes, I am. I just started my PhD after finishing my master over there. So, yeah, I'll be around for quite
Amazing.
well.
And still doing star formation, dust grains, all that good stuff?
Yes, I'm keeping on that. But however, I also shifted with we're looking at the remnant of stars, which like when they explode, so all those ionized gas stuff when the stars die. So, yeah, super excited.
Amazing. And of course, who better to talk to us tonight about all the kinds of planet stuff that we have lined up? And of course, I'll just go ahead and put out a little extra ad for your blog, which is on the archive site. So, in case folks didn't know, at the Allan Carswell Observatory, if you go to the Astronomer in Residence program, the AIR blog right now will show the 2024 astronomers who are out there this summer. But if you go into the archive at the bottom, 2022 has a wonderful archive from Parisa with, I believe, two photo galleries. So highly, highly worth checking out. And we're thrilled to have you with us here on York Universe as one of our hosts. So maybe I thought maybe we'd start off with you just talking a little bit about some of your outreach and science communication, Parisa.
Thank you so much for that. Such a warm welcome. I'm Parisa, and I started my master journey here in Canada back in September 2021. So I'm an international student here in Canada. I'm Iranian. So back at home, I had a lot of experience doing outreach when I was doing my undergrad back in home. But I think here I'm so grateful that the URC had that program that I could register because that happened to be my very first outreach program, which I really enjoyed it a lot. That I happened to go for 2 weeks as an astronomer residence in Killarney Park, which was a incredibly amazing place to be. And honestly, at the very beginning of doing that, I was a little bit scared because English is my second language. So that happened to be my very first public speaking. So I was quite nervous, but it turned out to be very good and I enjoyed it a lot. I just wanted to thank also the York Universe and York University Observatory that it just open up that opportunity for people like me who are interested in outreach and clearly see values in them to just go and explore that and gives it just gave me a lot of opportunity. What I'm so grateful about it, just like once you, I think not only me, but only other graduate student, the more and more like graduate student doing outreach program, the more and more like we become very comfortable in doing public speaking. So, and I think it's not only for outreach and the joy out of it, generally, but it also really helps me to be more comfortable when I go to the conferences or even for my presentation or journal clubs in the university. So I think it really does matter to practicing these things because it's useful not only for us, but also for the others. Because I believe that when I was a kid or when I was like teenager and when I was in my undergrad, like these were like these kind of program that keep me involved, and I just found a lot of joy in doing this. And I believe it also helped people to see, oh, astronomer can be a career that we can do, right? Because yeah.
Yeah, absolutely. And it's great stuff. And I will just go on record saying, Teresa, for all you say you're not maybe an expert speaker, but you had rave reviews from Killarney Park. They loved you out there.
Oh, thank you so much. They were lovely themselves.
So
Yeah,
you,
but yeah, so I just like honestly, I think it's really important by doing this outreach also to give that message to the younger people who did not like just do astronomy particularly as a career, to actually tell them it's not the only knowledge which was really abstract and it just carried along and passed it to us as a legacy, but it's only and it's also can be done as a profession. And also because a lot of people do not know, and I have a very funny, like just saying that because it's a very funny story that I have a very funny uncle that he keeps calling me every week and then asks me, "What are you good for?" And I'm like,
Oh,
well, maybe I'm not having any quick answer for you. Like I'm not like pretty useful for a day-to-day based life, maybe, but the technology that it's been used for astronomy, actually there was a foundation of having or like making us to have our very basic technology like our phone, right? Or our camera. So I think doing outreach, especially in astronomy, it gives that message to people that it's not only for our curiosity, but it also has a direct application our day-to-day base life.
oh yeah, absolutely. And it's funny because a lot of people would think of astronomy as like, oh, you just go out and look at the stars, but so many technology has been developed for the science, out of the science. Um, and so many things can still happen to affect that technology. Like one bad solar storm, say bye bye to your cell phone for a bit.
exactly. Or say hello to some aurora.
Yes.
or both, but and it's just great to be able to share some of these wonderful things that are out there in the universe with people because I think a lot of it, as you said, Parisa, it's sort of giving access to, you know, our knowledge, but also just the things that are up there for everyone to see. We can all go out and look at, I mean, if you're in the northern hemisphere with clear skies and it's the right time of year, you can go out and look at the Andromeda Galaxy naked eye with your eyeballs and then look at it through a telescope. And it's so fun. And it's such a good thing to share with people because it's something that's there for all of us to have. And even if you don't go into astronomy as a career, it's still for you.
Exactly. I'm always like having a funny term. I call the stargazing like my astrotherapy
Yes, I
mode.
agree.
That like, you just go and then see outside and just like I'm a speck of a speck. So maybe, I mean, our day-to-day base life is very, very much matter and we need to take care of it, of course, but it just gives you a kind of a big picture that well maybe it's just for joy. So I think for me at least it just works as a therapy. I'm like that's very useful.
Yeah,
Yeah,
absolutely.
I'm right there with you as well. Go outside, take in the sky, breathe in, breathe out.
Yeah, and I think you'd be better like use that opportunity since it's summer because like Canada in winter it's pretty much not fun to be. I mean it just I'm talking on behalf of a person coming from a south part of Iran in a country which was relatively warm. So it took me time to adjust to Canada's winter for
I was born
stargazing.
here and I still hate it. So I'm with you.
I
Enjoy the summer, even though
I
it
don't
means
mind
less
the
observing
dark
time.
yeah, I mean that's what I'm saying. I don't mind the really long dark skies. I mean that part I could get used to. Um but
Oh, it
yeah.
just gets so cold.
Well,
Yeah, but even though if like the night sky in winter is much clearer,
Yes.
so yeah, because all about the humidity and all those things. So, yeah, I mean, winter, if you want to like enjoy all this beauty, you might just bury the hassle a little bit.
yeah, and I mean this is why I'll just go ahead and throw this out there. Robotic telescopes. Um, so this is just turning into a mini advertisement for our telescopes at York, but I don't care because it's so nice to be able to stay warm and use the telescopes. And right at this time of year, stay cool and use the telescopes. So hopefully our crew is doing the setup okay. I saw that they're now aligned with the open dome, and the our OPV should be getting on Sky in a little bit. So
Nice.
very exciting times. Speaking of going places and times, I
Yeah.
suppose.
Let's
Shall
jump into our space and astronomy this week in history, shall we?
All right. So as a welcome for Parisa, we're going to go ahead and talk a whole bunch about planet things.
Wow.
um, uh, or adjacent, planet and planet adjacent, I think. So I can take us back. I'm not going to go too far back. I'm going to stay in this 2000, but go back to 2003. This week in space and astronomy history. So July 10th. So in 2 days, back in time to 2003. There was a pretty interesting planet that was detected outside of our own solar system. This is a fun one. It's got all kinds of interesting names actually. It was called PSRB 1620-26b, which is a terrible name, but it has a great nickname. It was called Methuselah, and apparently it was also called the Genesis planet, but the Genesis planet nickname did not come from the planet that Mr. Spock was buried on in the Star Trek movie, but actually it came from biblical references. So I was like, oh, I know this reference, and I didn't. But both the Genesis planet and Methuselah were biblical references to the oldest person. So the oldest person ever. And this particular planet, when they found it, they were able to date it based on the star that it was around and when they think the system would have formed. Um, and it is really, really old. So the planet is estimated to be about 12.7 billion years old. So this Methuselah planet was discovered using information from the Hubble Space Telescope, and they had tentative discoveries, but they hadn't confirmed it until they had the Hubble Space Telescope go out, and they were actually able to not just confirm the planet, but also confirm some properties of the binary that it's in. So it's actually a planet in a binary system, which is already odd. I think, oh, two stars, but both of the stars are really odd. So one of the stars is a pulsar, and the other is a white dwarf. So this planet survived the death of not one, but two different stars and still managed to stay in orbit. It has a mass about twice of that of our own planet Jupiter. And the really incredible thing is 12.7 billion years old. So this would have been off in early universe times we're looking at here. This is much older than any other planet that was discovered up until that time, so 2003. The oldest ever planet, much like the oldest ever star, are things that people are always looking for because if you do find it, these objects would have been made at a time in the universe that was very, very different from the universe we know today. A much more active, much more dense universe. And the binary stars themselves, a neutron star with a pulsar. This is an extremely extremely extreme is one way to say it system. So if you have a star like our sun, which is a what we think of, most of us think of when we think of star, if that star, which is tremendous in size, was shrunk down to the size of a white dwarf for the same exact mass, one solar star, a white dwarf is around the size of Earth, but with all the mass of a star like our sun. So it's very, very, very dense, very, very compact. A neutron star would be to shrink our sun into like the size of the Toronto general area. So these are extremely compact, extremely dynamic residuals left over after stars end their lives. And the planet is still there. It didn't get destroyed. It didn't get deorbited or whatever. Its orbital period is quite long, so 36,000 days, but the semi-major axis is only 23 AU, so around the binary, and it's really, really, really old. And I did actually have quite a hard time finding any other planets that were confirmed as older than this. I eventually found in the Open Exoplanet catalog, there are a few planets listed with ages of around the same, which is 12.9 or 13 billion years old. So billion. Many, many, many times older, or many, many, many times older than anything else in our area. And there's a few that have 14 billion year age, but the error bars are 4 billion years. So ages are a challenge to estimate, and this one is still one of the oldest that we know of. And of course, being an interesting planet around a pair of interesting stars in a very dynamic system, you might wonder why haven't we heard more about this? It is very, very faint, so it's hard to see. If we want a chance to be able to view it, you have to look towards one of the Messier objects, and I actually forget which one off the top of my head. I believe it's in M4, that's what it was, Globular Star Cluster M4. So if you've got M4 visible, you can see the globular cluster. It's about 5,600 light years from Earth, so it's in our own Milky Way galaxy. But these globular clusters tend to be very old objects formed in the early universe, and they're residuals from our own galaxy's early formation, we think. So it's an extremely old planet around residual, basically dead bodies of leftover stars, which is the binary that's there, in a globular cluster. And if you want to look towards it and you don't have a telescope, you can just look towards the constellation of Scorpius, which is always a fun one. Gets better roundabouts of November, I think, in the northern hemisphere. So, really fun planet discovered, or I should say confirmed July 10th, 2003. And as of today, if you go to Open Exoplanet catalog or the NASA Exoplanet Archive, I couldn't find very many others that were confirmed as definitely older. So feel free to go in and have a look yourselves. It's pretty fun.
Okay, that's just wild.
Yeah, Methuselah the planet. um,
Not that there's a contest for like wildest item this week, but you won.
it's pretty cool. Yeah, I mean it's a binary system with a neutron star pulsar, a white dwarf, and one of the oldest planets that's ever been found. Um, so
I
just
think it's my
bizarre.
new favorite.
Ooh, controversial. New favorite planet.
Hmm.
Harisa, do you have a favorite planet?
Yeah, mine is Jupiter.
Well, this one's bigger than Jupiter.
Oh. I don't know. I'm kind of attached to Jupiter because, as a practice, I just calculated the orbit of Galileo's moon around the Jupiter when I was undergrad. So I
Oh,
just ended up
nice.
observing that a lot and a lot and a lot. So just, and I'm like, Jupiter is my favorite.
Oh yeah, well, and I mean, you're gonna get a lot more detail off of the surface of Jupiter than you are from this,
Oh,
because
yes.
right now all you will see are artists' impressions of what it might be like around this planet. And I will just say, just imagine you are around something, you're near about something that is 2.6 times the size of Jupiter, 2.6 times the mass of Jupiter. So this giant gassy, Jupitery thing hovering in space, maybe glowing a little bit, definitely in the infrared, but there's no nearby star because even though it's only 23 AU, at 23 AU, there's this binary that's a neutron star and a pulsar. So your night sky and your day sky would both be just stars. It would just be like this gas planet hovering in the darkness with those two little fragments of leftover stars off in the distance. Like wild. Anyways, I'm making a case for Methuselah planet to be um, imaged in more detail.
Okay, I'm convinced now. I shift to this one.
It feels like a very interesting setting if it has a moon for like some sort of sci-fi
Oh yeah.
something.
Yeah, for sure. This would be a great setting for all kinds of stuff. And I mean, being the a surviving planet in a system like this, even if there were other planets around, who knows how many of them would have survived both of those stars going, right?
Oh, so
Um,
cool.
yeah, planets are really fun.
All right. Well, let's move from the discovery of one planet to the discovery of another.
Yes,
Uh,
let's do it.
all right. So we're
More
going to
planets.
July 6th, 1995, and the discovery of 51 Pegasi B, also known as Dimidium.
Ooh, cool
I
name.
Yeah, I didn't realize it had a name other than 51 Peg B, but
Yeah, let's go by the names more because Methuselah, Dimidium.
yeah. And Dimidium is like an official name. It's not a nickname, but we'll get
Oh,
to that.
okay.
So this is the first exoplanet orbiting a main sequence star to be discovered. And 51 Peg is a sun-like star. It There had been several terrestrial mass planets that had been discovered orbiting pulsar PSR B1257 plus 12 in 1992. But this was the first around like a main sequence star, a star that was not dead. And the discovery was made by Michel Mayor and Didier Queloz at the Observatoire de Haute-Provence in France. 51 Peg B is about 50 light years away from us in the constellation of Pegasus, and it is the prototype for hot Jupiters. Traces of water were discovered in its atmosphere in 2017. And Mayor and Close won jointly the Nobel Prize in Physics in 2019 for the discovery. The name Dimidium comes from the IAU's Name Exoworlds project, which was launched in 2014. And the name itself was submitted by and now I butcher the German, Astronomische Gesellschaft Luzern, or the Astronomical Society of Lucerne in Switzerland. And dimidium is from Latin. It's Latin for half, referring to its mass being half the mass of Jupiter's.
Yes, Jupiter again.
Yes, although when I first saw it, I was like, DIMI, Didier and Michel.
Oh.
I feel like there might be a little bit of a coincidence there, maybe. I don't know. Before its official naming, Dimidium did have an unofficial nickname of Bellerophon that was given to it by astronomer Geoffrey Marcy, who was following the convention of naming planets after Greek and Roman mythological figures. The discovery was made using the radial velocity method with the Elodie spectrograph, once again at the Observatoire de Haute-Provence in France. The pair firmed up their data in July, and the discovery was announced later that year on October 6th and published in Nature. Dimidium orbits 51 Peg at a distance of just 7 million kilometers. And within a week of the announcement, a team using the Lick Observatory in California confirmed the observations. Many teams made observations after the announcements. And so more was discovered about the planet. Its orbital period is 4 days. It moves around its star at a speed of 136 kilometers per second. The minimum mass, as I already mentioned, is half Jupiter's mass. Making several assumptions, it has a bond albedo of 0.1 and a temperature of 992 degrees Celsius. It is tidally locked with its star. It probably has a greater radius than that of Jupiter, despite its lower mass. And that is because its superheated atmosphere must be puffed up into a thick but tenuous layer surrounding it. Beneath this, the gases that make up the planet would be so hot that the planet would glow red, and clouds of silicates might exist in the atmosphere. At the time of its discovery, having a gas giant so close to the parent star was considered an anomaly, but subsequent discoveries showed this to be pretty common, which caused astronomers to really start asking questions about everything we thought about solar system formation.
Oh yeah, I remember that. It's because it's one of the easiest planets to find is a large planet close to your star.
Yeah.
Because it's going to make your star do things that are easy for us to find. So it'll make the star wobble more. It will make the light go down more. It will make the spectroscopic signal more clearly. So everything we have that lets us find exoplanets works better if you have a massive star or a massive planet near your star. But that's not how our solar system looks, and so we weren't super duper expecting to find all that many of them. But there are so many stars in our galaxy. It turns out that even having this massive selection bias, we can we s- I forget how many hot Jupiters they found now, but it's quite a few.
Oh, yeah. And I remember, right, like this was in 95. I started my degree in 98. Like, how many talks did I go to about like, are is our solar system the big anomaly, or is the method biased for this kind of system?
Oh,
Time
it's
will
yeah,
tell.
it is biased,
Oh,
totally.
yeah, absolutely. At the time, though, it
Yeah,
was like, this is what we're finding.
yeah. I mean, one advantage to the 51 peg system is this is actually a system that you can draw on a piece of paper on the correct scale next to itself, right? So if you draw
Yes.
the star and the planet on an 8.5 by 11, you'll be able to see both of them, which is not possible in our solar system because of those extremely large distances that go out um, to, the planets we know and love.
Yes. All right.
Um,
Let's sneak in your third this week because it dovetails so beautifully.
Yeah, so I have one more. It's on the planets, so staying on planets and staying on the same general theme. I just couldn't resist putting in a little this week in space and astronomy history for one of the big, I suppose, one of the big wins, one of the big successes in astronomy and the massive revolution in planets outside of our solar system. Kepler Planet Finding Space Telescope. So we're going to go back to 2012, July 14th. The Kepler Planet Finding Space Telescope is in orbit, and it is out there doing amazing things, finding exoplanets that we would never have been able to find before. But yeah, this week in history, so 8, 9, 4, 6 days from now, and back in 2012, just to do my math, 4, 6. Um, 2012, this amazing resource, this beautiful telescope that's in space and no longer accessible, has a failure. And this is one that also just um, was such a huge deal when it happened in 2012. One of the four reaction wheels pointing the spacecraft and actually allowing it to point to where you wanted it to go on the sky stopped turning. And everybody that I know at the time that was at all interested in planets just like sort of held their breath and went, oh my gosh, what are we going to do? And they figured out that they could complete the mission for Kepler if and only if all three of the other wheels kept moving. And of course, the Kepler Space Telescope has observed a tremendous amount. So this is a really really fun telescope. It is defunct now. It was launched back in 2009, right? So this is several years later that it had the failure. Um, and after about 9 years of operation, it was out of fuel. So this failure that they had in of one of the wheels, uh, was a little bit. It could have ended its life a little early. So this is 2012, and they wanted to keep it going as long as possible. So in the end, I'll just like put a little spoiler out there. They were able to keep it going until it ran completely out of fuel in 2018. So October 30th of 2018, and that's when it was officially retired from service because they had no more fuel for it. But they have a photometer, and what they were doing was monitoring the brightness of about 150,000 main sequence stars in a fixed field of view. Because if you want to find an extra exoplanet, you have to watch the star through usually several orbits of the planet. So if you were trying to find Earth and you were around another star, you would need to watch our sun for a couple years, at least two probably, and be able to pick out the signal of Earth as it went around. If you wanted to go and find Jupiter, it would be even harder, right? Because Jupiter's orbit takes a lot longer. So Kepler, by observing a tremendous amount of stars and having these fixed fields of view, they were able to get more detections. And I believe there are still people combing through that data. In the end, they've got 530,000 stars, a little over 530, 500 and something. And right now, there are over 2,700 confirmed planets. And so these are planets that they have got a signal for, and then they follow up and they confirm that it's a real signal and that it's really a planet, and hopefully some of the properties as well. So being able to run it for those extra couple years added thousands and thousands of more planets, and it helped us probe into the low mass range for planets as well, because finding massive planets very close to stars is easy. Finding low mass planets farther out is very, very hard. And so now we've basically been able to show that it really is limited by our ability to see these planets. They're out there. The low mass planets farther out from their stars, they're totally out there. We just haven't been able to see them. And we still can't see a lot of them actually. um, but there's wonderful maps showing the trajectory of the of Kepler and its sort of lifetime and all the planets that they found and the follow-up for the existing planets. And if you want to get into the full exoplanet archive, I'll just recommend the NASA Exoplanet Archive, which I believe allows anyone to create a login for it. But they have basically a nice list showing the different planets with all the measurements they've been able to take out. So distance, magnitudes, and Gaia data if they have it. And now we're really building on Kepler's amazing legacy here. So it's a really good thing that they were able to fix the remaining three wheels to keep the telescope pointed on the sky and get those few extra months of data collection out of it. So they did have the first one fail, of course, as I say, this day in space and history, 2012. The second one failed in 2013, which disabled some collection of science data, but it basically meant that when they got to the final fuel in 2018, they didn't try to do any continuation or anything. It was November 18th, 2013, after the second wheel had failed, they got a second light proposal, which disabled Kepler in a way that could detect habitable planets around smaller, dimmer stars. And this was part of what's called the K2 extension. And this actually helped another, I think, over 3,000 extra planet candidates. So there are just planets out there like you wouldn't believe if you're able to see them. They're just really, really, really hard to see. And I
Yeah.
think no spacecraft has helped show that better than Kepler. So it's too bad that it did retire and run out of fuel. But for 9 years and over, it's going to go over 3,000 exoplanets at some point out of the
Oh
data,
yeah.
I'm sure.
It did its job.
Yeah, it was massive, massive success. And I'm the mind boggles when you think about collecting one extra exoplanet. Before we had Kepler, that's what we were doing.
Yeah,
And now we're rolling in exoplanet data, which is great because there's a lot of really interesting ones out there.
for sure. All right, folks, you are listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. head over to www.yorku.ca/science/observatory for chat, questions, content. Find us on Instagram at YorkU Observatory. Tonight, you're listening to Julie Tomei, Dr. Elena Hyde, and Parisa Nazari. We have just wrapped up our This Week in Space and Astronomy History. Elena, do we have any reminders this week?
We do actually, and it's just a very happy coincidence, I suppose, that we've been talking about the astronomer in residence. We do have a reminder if you are interested in the astronomer in residence happening now with the observatory and Killarney Provincial Park. Our next astronomer for 2024 starts on July 29th, so in about 20 days. But there are already blogs for the astronomers who've gone so far, so you can check that out. See some amazing astrophotography, beautiful dark sky pictures that will just make you want to be there. Highly, highly recommended. And the second announcement I will just put out is that this is July 8th. We are doing an in-person tour. If you're in Toronto and want to come out to York University, July 10th will be an atrium tour. So this is weather dependent tour. It must be clear, but if it is clear, we'll be on top of the Arboretum parking garage and you can get your tickets on that amazing same website that Julie's been giving you, which is yorku.ca/science/observatory. All the tickets are free. So hop on over and if it's clear, we'll see you on Wednesday.
Nice. All right, let's get into some news. Parisa, would you like to go first?
Yeah, absolutely. So
Go for it.
I came across with a very nice news on July 1st from sciencenews.org with the title of Stellar Explosion May Add a Temporary New Star to the Night Sky this Summer. So apparently, there's an incredible celestial event brewing in a constellation called Corona Borealis. So keep your eye on that. It might look like a new star in that constellation appearing in the night sky, but hold on, it's not a new star. It's going to be a nova eruption happening about 3,000 light years away from Earth. And what's going to happen is just that a white dwarf star is orbiting around a red giant in that constellation, and it's pulling material from its larger companion. So when enough material accumulates on the white dwarf surface, then boom, spectacular blast will occur. And then it will be visible to all of us on Earth for just a few days to a week. And that's very satisfying, but you might ask that what is a nova? So just in case if you do not know, nova traces back to Tycho Brahe's 1573 observation of new object in Cassiopeia, and the term called de nova stella in Latin language, meaning on the new star. And today, we understand these novae as powerful eruption from white dwarfs, which white dwarfs are the dense remnant of stars that have shed their outer layers. And when a white dwarf accretes material from a nearby star, it can trigger these explosive events. Also, the white dwarfs and red giants together from a binary system known as T Corona Borealis, or TCRB for short. And just a reminder, a red giant is also a luminous giant star of low or intermediate mass, like around 0.3 to 8 solar masses. And what happens is that, like, when the stars ran out of the hydrogen fuel for nuclear fusion in the middle, it has begun the process of dying, and that makes a gigantic red hot ball, which it expands its radius, and just the surface temperature goes up around 5,000 K, corresponding to 4,700 centigrade or 8,500 Fahrenheit. And the astronomer mostly they're located in Columbia University, and the University of, let me remind myself the name. What was it called? The Nacional, I have it. The Nacional, I don't know, I cannot like honestly, sorry, pronounce it. There's like a university in Argentina where like those astronomers who predict that nova basically that could happen anytime between now and September. And interestingly, this TCRB tends to erupt approximately every 80 years. And then the last event occurred in 1946. And this TCRB has shown recent signs of activity like brightening and then dimming, so which suggests that nova is happening soon, or at least ready to take places. But just because the space is a mysterious uh, thing out there, so that's like highly probable that will happen. But some astronomer says like maybe you're gonna look up and then waiting 10 years and still like that will not bright. But this pattern was observed before its eruption in 1946 and 1866. So it's highly probable that will happen again. And it's a once in a lifetime opportunity. So we're in the right time, right moment, with the right instrument, because right now we have all the facilities, space telescopes, and everything. They're ready to observe it in a very close detail. But just because it is a very interesting event happening, not only because of that, because it also can bring up so many questions, like were those dust and gas that actually responsible for making the stars are created? Because once this explosion happened, it just actually deposited a lot of material into the space, and that white dwarf loses a bunch of masses. However, some of those masses like go back to its surface and also gain that mass. But this very dynamical, very chaotic explosion change the interaction of this gas and molecules with the molecule clouds, and it really affects the influence the formation of the next stars that will born in those molecule clouds. So it's really important for galaxy evolution, for star formation studies, which surprisingly that these questions are still very open questions, and we actually do not know where all those dust and gas forms. And people predicting that after the eruption was over, astronomers attempt to measure the mass of this white dwarf to see how dense it is to be able to answer those questions. So stay tuned and look up from now to September. Hopefully that erupt and we can catch that beautiful events. But the bet is that these kind of events usually going to be detected by amateurs first, which is a very nice other things, right? I mean, astronomers do a bunch of science, but these are amateur astronomers that are obsessed with the night sky, go out there doing a lot of photography, tracing the night sky all the time, and boom, suddenly a lot of exoplanets or these celestial events usually detected by amateurs. So very happy stargazing.
Absolutely. This is a great thing to look out for absolutely everybody. Even if you've just got binoculars, wander out and have a look towards the constellation and be like, so are there any stars that shouldn't be there? But yeah,
Exactly.
Of course,
this
if you
is
happen to have a 1 meter telescope,
I'm just saying, yeah, I mean, if you happen to,
it's
might as well.
which is pointed at it like right now.
We just go wherever we want to go really, and yeah, T Corona Borealis I believe is the target they're going to next over
Yes,
there.
yes, it is.
So that's going to be, I mean, obviously we've collected as much data on it as we can because as mentioned, it was 1946 the last time this went, and there were astronomers watching, but not really all that carefully, right? So they weren't monitoring it at a very high. frequency. They didn't know that it was going to happen. And so when it went nova, the light curve that they got, it's like, could be better. And some of the signals that they saw are a lot lower resolution than what we can pick up today.
Hmm.
So not just, being able to get more information out of the same signal, but also, using additional instruments and additional telescopes. And there's so much information we could get out of this if we just happened to be observing on it as it went, then every exposure that you take will be telling you something unique about that particular explosion, which just makes it so, so tempting. But even if you miss the start, it's still worth taking as many images as you can because catching the behavior of the dimming over however long it takes for it to dim. So, there's a huge variation of how long it might take to get dim again. That as well can get you a tremendous amount of information. So, yeah, could
Yeah,
erupt to
and
any year, month, day now.
yeah, and then one thing which is cool about those nova is just those repeated nova actually can lead to a much uh like powerful explosion. And then at the end they might like lead up to type 1 supernova, which is now they're nova, but as they accumulate and then materials on the surface of the white dwarfs, then they just gonna explode like much more energetic. And then the type 1 and supernova, for those who do not know, they just a type of nova that it occurs in a binary system when the two stars are orbiting one another. So, which is one of the stars is white dwarf, which is this case. Yeah,
Yeah, exactly. And it's a great system to keep an eye on.
Note to self,
So
especially
like
when I'm up at Killarney.
yes, and especially when you're up at Killarney. And I mean, it's a great example of the extreme nature of the white dwarf, right? Because it's not just accreting matter, it's accreting matter down into a deep gravitational potential well because it's got so much mass and such a small radius. And this stuff that's coming on to this, basically giant space diamond that is a white dwarf, like extremely hot compact space diamond, um, that it's going to be heated up to an incredible amount and it's going to try to go onto that surface, and that's why it's going to reach this ignition temperature. It's an extremely uh, you know uh, dynamic process. And there are cases where they've always wondered, like, okay, well, what if something happens during the accretion of material? Could you actually get a blast that would be big enough to destroy the white dwarf? How much of the accreted material goes away? How much of the white dwarf goes away? You know, how does this process exactly work? And all of that, as you mentioned, enriches the area of the galaxy around it, putting tons of heavier elements out into space so that we can create more interesting rocky planets to go walk on. Very fun
Okay.
stuff.
Yeah, thank you for that amazing story, Parisa. All
Yes,
right,
that's a
Elena.
very good one. So do you want to do the Jupiter one or the Neptune one?
Well, that's what I was going to ask you.
I can do the Jupiter one really quick. How about that?
Okay, let's do that one.
All right, so there's a fun little story out right now about Jupiter, which is basically Jupiter's great red spot is not. It's a lie. Oh my gosh. So it's out in Science News. It's been put out by the American Geophysical Union, and it's a study that was done on Jupiter's Great Red Spot, on the origin of the Great Red Spot, actually looking at how this storm develops over time. And what they're proposing is a little bit radical. They're proposing that the Great Red Spot that you and I can see on Jupiter's face, which has persisted for at least 190 years, right? This is likely a different spot from the one observed by the astronomer Giovanni Cassini in 1665. So it's a little bit of a like it would just change dramatically what we think of Jupiter, because Cassini did report in 1665 something that sounded an awful lot like the Great Red Spot, and I, for one, had always assumed it was the same one. I was just like, oh, it's an incredibly persistent storm. We know this Great Red Spot has persisted for 190 years. Why wouldn't it be the same storm? So what they're proposing in this new paper that's just come out is that so this is literally a couple weeks ago, I guess, about a week ago. They're proposing that the storm we see now was formed in an instability which produced a long persistent atmospheric cell, but that instability would not last over infinitely. Um, it would probably disappear somewhere between the mid 18th and 19th centuries. And in which case they're proposing that the longevity of the red spot and red spot like systems, I suppose, would be about 190 years. So, it's an interesting study and it's a little bit tantalizing and it's just out now. So, if you want to read an argument for why the Great Red Spot might not be the same one as the one seen in Cassini. It's out on Science Daily, and I believe the preprints are also on our archive for free to download. So you can get into the geophysical research letters, and the actual PDF is a little bit daunting, but it has some pretty cool pictures in it. So they've basically done some very, very advanced modeling to make this argument. So have fun, and that's the Jupiter one. And I think we have just enough time to quickly talk about the last one.
Yeah. Okay. I'm a little shaken by this Jupiter one, Elena.
I know this is radical. We can save Neptune for next time if you want.
No, let's talk about Neptune. Let's do it.
All right, Neptunes
All right.
and sub-Neptunes.
Sub-Neptunes. Yeah, it's not about Neptune, it's about sub-Neptunes. Okay, so the density difference of sub-Neptunes finally deciphered. So the most abundant type of exoplanets are sub-Neptunes, and these are planets that are between the size of Earth and Neptune. It's estimated that 30 to 50% of sun-like stars have at least one of these planets. Finding the density of these planets poses a problem depending on the method used to determine the mass. Two populations are highlighted, those that are dense and those that are less dense, leading to the question, is this due to a bias in observations, or are there in fact two distinct populations? So there's a team from the NCCR Planet S and the University of Geneva and the University of Bern that argues that the latter, that there are in fact two distinct populations, is the case. And they published in Astronomy and Astrophysics. So to estimate density, you have to find the mass and the radius of the planet, and that's done via one of two methods. One is the transit timing variation, or TTV method, and the other is the radial velocity method. Planets measured using TTV are less dense than those measured by radial velocity. The TTV method measures variations in transit timing. Gravitational interactions between planets in the system will change the moment at which a planet transits their star. And the radial velocity method measures the variation in the star's velocity because of the planets around it. So the team studying this question thinks this is not a case of observational bias. The majority of systems measured with TTV method are in resonance. So in other words, the ratio of your orbital period is a rational number. And the team wondered if there is a relationship between density and resonant orbital configuration of a planetary system. So basically, first, they did a statistical analysis. They had to rule out bias in the data by selecting systems for statistical analysis. For example, large low mass planet detected with transit takes more time to be detected with the radial method, and that increases the risk of observations being interrupted before the planet is visible in radial data. And so they had to choose their systems carefully. And then once their data was cleaned up, the team used statistical tests and found that the density of sub-Neptunes is in fact lower in resonant systems than in non-resonant systems, regardless of the method used to find their mass. So, why does the link exist? Several explanations have been suggested, but the main hypothesis given by the study is that all planetary systems converge towards a resonance chain state in the first few moments of their existence, but only 5% of systems stay stable. And the rest, the resonance chain breaks down. This generates a series of catastrophes like collisions that fuse planets together and thereby increases their density. And then after that, it stabilizes into a non-resonant orbit. And that creates the two distinct classes of sub-Neptunes.
Oh, interesting. Resonances are crazy.
Yeah.
That is also a really fun one.
Yeah. All right, folks. We are at the top of the hour. You've been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Dr. Elena Hyde, Parisa Nozari, and myself, Julie Tomei. You can always connect with us on Instagram at York U Observatory, on Facebook at Allan I Carswell Obs, through our website at yorku.ca/science/observatory. Thank you for tuning into York Universe. Clear skies and have a good night.